Have you ever really looked at a simple piece of paper? I mean, really looked at it. It seems so basic, right? But the journey it takes from being part of a massive, solid tree is honestly one of the most incredible industrial stories out there. So today, let's unpack this amazing transformation from a log in the forest to a page in your library.
So, right off the bat, here's the big question we're tackling. How on earth do you take something as tough and rigid as a log and turn it into something you can fold up and put in your pocket? Well, the answer is this really cool mix of brute mechanical force and some super smart chemistry.
All right, before you can build paper up, you have to break wood down. And that brings us to our very first challenge, what I'm calling the paper problem.
You see, wood is basically made of these really valuable cellulose fibers. That's the good stuff we want for paper. But all those fibers are locked together by this powerful natural glue called lignin. It's the stuff that makes a tree, Strong, rigid, able to stand up to a storm. The whole trick to making paper is figuring out how to get rid of that glue without wrecking the precious fibers it's holding on to.
Now, there are basically two ways to do this. On one side, you've got the brute force method, mechanical pulping. You just grind the wood up. It works, you get a lot of pulp, but the fibers are weaker. Think newsprint or paper towels. But on the other side, you've got smart chemistry. This way, you carefully dissolve the lignin, which gives you these beautiful, strong, high-quality fibers, the kind you need for books and nice writing paper. For our journey today, we're definitely going to follow that smart chemistry path.
And when we talk about chemical pulping, the undisputed champion is the craft process. It's the most common method used around the world, and honestly, it's a total masterpiece of chemical engineering.
Okay, I know this diagram looks a little intense at first glance, but don't worry. Just think of it as our map for the first part of the trip. We're going to follow the wood chips starting up in the top left, watch them go through this whole system, and see them pop out on the right as raw pulp, all ready for the next stage.
So here's the play-by-play. First, they take the logs, strip off the bark, and chop them into these little uniform chips. Then those chips get fed into that giant tank in the middle. It's basically a massive pressure cooker called a continuous digester. We're talking 30 meters tall. Inside, a hot chemical mix called white liquor gets to work dissolving that lignin glue, setting the cellulose fibers free. And finally, the whole soup is blasted into the blow tank, which separates our brand new pulp.
And getting this right takes an incredible amount of precision. It's not just about boiling wood. As this quote explains, the engineers have to nail the perfect balance of time and temperature. They need to get rid of as much lignin as possible without causing cellulose hydrolysis, which is just a fancy way of saying without damaging the good fibers. It's a really delicate chemical tightrope walk. So, success, we've made our pulp, but right now it's just this wet, soupy mess. The next part of the process is pure mechanical magic, turning this slurry into a perfectly uniform, solid sheet of paper. So we're starting with this watery mixture of our cellulose fibers, and when I say watery, I mean it is an unbelievable 99.5% water. Seriously, less than 0.5% of this stuff is actual fiber. So the entire challenge from this point on is just one thing: get rid of all that water. And this is the beast that does it. This is the paper machine. It's this enormous piece of equipment, sometimes as long as a football field, and it has one job: systematically get all that water out by draining, pressing, and drying. Let's see how it pulls it off.
All right, first, that slurry gets sprayed out onto a giant moving wire mesh screen. Gravity and some vacuums pull tons of water out right away, leaving behind this fragile mat of fibers that's still 80% water. Next, that wet sheet runs through a series of huge rollers covered in felt that literally squeeze more water out, getting it down to about 60%. And finally, the paper snakes its way through this huge section of steam-heated cylinders that evaporate all the rest of the moisture before a final set of smoothing rolls gives it that finished surface.
And here we are, the final product. After that incredible sprint of draining, pressing, and drying, the finished roll of paper has a moisture content of only about 5%. Just think about that. In a matter of minutes, we've gone from basically pure water to a solid sheet of paper.
Now, you might be thinking, wow, that process sounds pretty intense, especially with all those chemicals we talked about. But this is where the true genius of the craft process really comes into play, with a surprisingly sustainable chemical loop. And it's a totally fair question to ask, right? Do they just get thrown away? The answer is absolutely not.
For this whole thing to work economically and environmentally, they have to get those chemicals back.
So, remember that used-up chemical soup from the digester? That stuff has a name: black liquor. It's a mix of the spent cooking chemicals, water, and all that lignin we worked so hard to dissolve. It might look like waste, but it's actually incredibly valuable.
Here's how they close the loop. First, they evaporate a bunch of water to make the black liquor more concentrated. Then, they burn it in a special recovery furnace. And this is the brilliant part. That dissolved lignin is packed with energy, so burning it actually creates steam and power for the rest of the mill. The fire also recovers the inorganic chemicals as a molten liquid, which they dissolve to make something called green liquor. Finally, they just add some lime, and that turns the green liquor right back into the original white liquor, all ready for a new batch of wood chips.
And get this, here's the real payoff. This recovery cycle is so incredibly efficient that modern paper mills recover and reuse 98 to 99% of their cooking chemicals. It's a nearly perfect closed-loop system, which is what makes the whole thing viable. Amazing!
So, after all that incredible chemistry and massive mechanical engineering, what's the point? Well, the point is we get the countless paper products that are just everywhere in our modern world, all thanks to this one fundamental process.
Those strong, high-quality fibers created by the craft process, well, they become the books we read, the packaging that keeps our stuff safe, the paper towels in our kitchen, and just so much more. This single, ingenious process is the backbone of a huge part of our world.
So yeah, the next time you pick up a book or just jot down a note on a piece of paper, maybe you'll think about the wild journey it's been on. From a towering tree to a chemical pressure cooker, through a gigantic water-squeezing machine, all powered by a nearly perfect recycling loop. It is anything but simple.